Okay, and one final note that I want us to take away from this activity before we move on to our third activity is a reminder of why it's important to be able to establish that one figure is a dilation of another figure. Because remember, what do we know about dilated figures, right? Let's think about the two pieces of information that we have, right? We have lengths and we have angles of dilated, of any figure, right? So there are two things that we know about lengths. The first thing that we learned about lengths of dilated figures all the way back in like Unit 3, Lesson 1, was that lengths are proportional. Okay, lengths are proportional. And we added on something to this in Unit 3, Lesson 4. We learned that lengths are not only proportional, but they're also parallel, right? So not only is AN proportional to AC, but it's also parallel. It's going, well, in this case, they're not parallel because they're going, it's the exact same line, but they are going in the same direction. These sides right here would be, these sides would be parallel because they are going in the same direction and they are not the same line. And then what do we know about angles? Angles are congruent. Okay, so I know that this angle in here is the same as this angle in here. This angle in here is the same as this angle over here, etc. Okay, so and this angle up here is the same as this angle in here, right? So now the reason why I mention this is because I want to make sure that we highlight this part about knowing that lines are parallel, right? Because if we think about it now, we have a bunch of different ways that we can know for sure that two lines are parallel. One is we could use something that we learned all the way back in Unit 1, Lesson 20. We learned about corresponding, alternate interior angles, alternate exterior angles, right? And so we can use angle relationships to prove that we have a set of parallel lines. In Unit 2, we spent a lot of time talking about rigid transformations. And so, and actually we did this also in Unit 1 as well. We also learned that translated lines are parallel and rotated lines of 180 degrees are parallel, right? So that's our second method. And then now that we're in Unit 3, we have a third method. We can show that lines are parallel because they are corresponding lines of dilated figures, right? So that can help us later on when we want to establish that lines are parallel. If we show that two figures are dilations of each other, then we know for sure that corresponding sides are parallel.